Picture this. You're on a massive ship, miles and miles from shore, just the deep, dark ocean all around you. And then, suddenly, silence. The engines cut out. The lights go dark. The ship is completely powerless, just adrift. Today, we're going on a deep dive, hunting for the one electrical culprit that can cause this exact kind of catastrophic failure. The answer, and, the main suspect in our investigation today? It's the short circuit. It's this single, tiny event that can kick off a huge chain reaction of failures, basically turning a high-tech vessel into a dead-in-the-water raft. So what exactly is this electrical saboteur? Well, meet our culprit. A short circuit is basically what happens when electricity decides, nah, I'm not going to follow the rules. Instead of going through the normal path, through the motors, the lights, the equipment, it finds a shortcut, a path with almost zero resistance. And as we're about to see, when electricity takes a shortcut, the results can be pretty explosive. Okay, so we've identified our culprit. Now let's head to the crime scene. What actually happens in those first few moments after electricity takes this forbidden path? Let me tell you, the consequences are both severe and incredibly fast. First off, you're looking at a huge risk of a total blackout. And that's not just, an inconvenience. It's a massive failure. That insane surge of current creates intense heat, which means you've got a serious fire hazard from things like melting cables. That surge can also do permanent damage to the absolute heart of the ship. We're talking its generators and motors. And probably the scariest part, it can lead to a total loss of propulsion and steering. That is a sailor's absolute worst nightmare. So the damage is clear, but why? Why is it so destructive? To get that, we've got to put on our lab coats and analyze the evidence. It's time to dig into the actual science behind that surge. Take a look at this. The contrast is just night and day. On the left, in a normal, healthy circuit, electricity flows through a load, say a motor. That load has resistance, and that resistance keeps the current under control. But look at the right. In a short circuit, the current completely bypasses that load. And here's the key. The resistance, the very thing that was keeping everything in check, drops to almost nothing, almost zero. And this is the why of it all. It comes down to a basic rule of electricity, Ohm's law. Current equals voltage divided by resistance. Now, just think about that for a second. If that number on the bottom, the resistance, or R, gets incredibly, incredibly small, like close to zero, what happens to the result of that division? The current, or I, goes through the roof. It skyrockets to this massive, totally uncontrollable level. And that's the surge. Now, with something this dangerous, you'd hope a ship has some defenses built right in. And you'd be right. The moment a short circuit happens, a whole team of automated first responders jumps into action instantly. So your primary guards are the circuit breakers. Think of them as being on watch 24/7, constantly monitoring the flow of current. The instant they detect that huge abnormal surge from a short circuit, bam, they physically trip open, cutting the power in a fraction of a second. They stop the damage before it can spread any further. Then you have the silent sentinels, fuses. A fuse is just brilliantly simple. It's really just a little piece of metal designed to melt when the current gets too high. So when that short circuit hits, that surge just melts the strip, breaking the circuit. It literally sacrifices itself to protect the much more expensive equipment down the line. But hey, what if you could get a warning before disaster strikes? Well, that's the super important job of the Insulation Monitoring Device, or IMD. On a ship's power system, the IMD is kind of like a smoke detector. It's constantly checking the health of all the wiring. If it spots the very first sign of trouble, it sounds an alarm, giving the engineers a chance to fix the problem before it turns into a full-blown, catastrophic short circuit. Okay, so the alarm has gone off, a breaker has tripped, the automatic systems have done their part. Now, the human detective, the ship's electrician or engineer, arrives on the scene to solve this electrical mystery. And before a single tool even comes out, there is one absolute non-negotiable golden rule: safety first. This means that circuit is completely cut off from power, isolated. A physical lock is put on the breaker, that's the lockout. And a tag is hung on it, that's the tagout, warning everybody that this circuit is being worked on. You never, ever investigate a live circuit. So, once the scene is secure, our detective follows a very clear step-by-step process. This 7-step method is their roadmap. It takes them from identifying the fault to physically inspecting it, testing, isolating, repairing, and finally restoring powers safely without causing another problem. And of course, every good detective needs their toolkit. The multimeter is the go-to for checking resistance on that now-dead circuit to find the short. A clamp meter can be used on live circuits to safely measure current. But the real star of the show is the Megger. It's a specialized tool that tests the quality of the insulation itself, helping find the root cause, the actual breakdown in the wiring that allowed the shortcut to happen in the first place. So, when our detective uses that multimeter on the faulty circuit, what's the smoking gun? What's the one piece of evidence that screams short circuit? It's this number, 0 ohms, or something really close to it. That reading is all the confirmation they need. It tells them there is a direct, dangerous path for electricity to flow. The shortcut has been found. So, once that faulty cable has been fixed or the bad component's been replaced and it's been tested again to make sure everything's good, it's finally time. Time to close the case, safely bring the power back online, and maybe think about the lessons we learned. So, what have we learned from our little investigation here? Well, a short circuit is really just a simple failure, low resistance causing high current, but it has really complex and dangerous results. And while automatic devices like breakers are your essential guards, finding the root of the problem takes a safe, methodical, human investigation with the right tools. And all of this really leads to the most important lesson of all. The absolute best way to solve a short circuit is to stop it from ever happening. Which kind of brings us to our final thought. All these things we talked about, the alarms, the breakers, the troubleshooting skills, they're all reactive. They only come into play after something has already gone wrong. So, we'll leave you with this question to chew on. When you're on a ship miles from anywhere, is proactive maintenance the only real defense against the next electrical mystery?